Alright, let's learn what a conditional is. Did you know that the statement, if I was a 7-foot tall woman, then I could fly anywhere in the world, is actually true? So I want you to think about that for a second. I'm obviously not 7 feet tall, nor am I a woman. But if I were, then I could fly anywhere in the world. Now let's figure out why this statement is true, because I think most people would argue that this is false. Well, you'll notice that this statement has an if-then. So if-then, what actually occurs is we call this a conditional. You probably have heard this. If you clean your room, then you can go out. Now let's let A and B statements be the following. A, you clean your room, and B, you're allowed to go out. So how we would write this in a mathological sentence would be A, right arrow B. And reading that would be if A, then B. And now for some mathematical terminology. The if part, or in this case A, is called the antecedent, and the then part is called the consequence. So now we have an if A, then B. Also, we may call this a conditional. Let's look at the truth table values of this conditional. So again, we will start with the various values A and B can take on. And now let's see what the truth values of the conditional will be. Well, let's look at the first row. This says you cleaned your room and your parents let you go out. Well, I think you'd be pretty okay with this, hence the conditional would run true. The next row says you cleaned your room but your parents didn't let you go out. Well, now I think you'd be quite upset, and hence the conditional would run false. The third row says you didn't clean your room but your parents still let you go out. Well, again, I don't think you'd be upset, hence the conditional is true. And the last row says you didn't clean your room and you weren't allowed to go out. And once again, I don't think this would be a bad scenario, and hence the conditional would run true. And so you can see a conditional is only false if the antecedent, or the if part, is true, while the conclusion, or the then part, is false. Alright, let's discuss some possible equivalent statements to the conditional if A then B. Imagine your parents said to you, if you go out, then you cleaned your room. Well, you'll notice here that the antecedent and the consequence have now switched spots, and we would write this as if B, then A. The word we give this statement is called the converse. We're going to see, by the way of truth tables, whether this is an equivalent statement or not equivalent. As well as, imagine the statement your parents said, if you didn't go out, then you didn't clean your room. Well, now, once again, the antecedent and the consequence have both switched spots, but we've taken the negation of both statements. Hence, we would write this as, if not B, then not A. We call this the contrapositive. And now, let's determine whether these statements are equivalent or not. Alright, let's see the truth table values of these alternative statements. So as you can see, we are starting with the same truth table values that we started originally with the first if A then B. Now let's look at the fourth column. If you remember, a conditional is only false if the antecedent, or the if part, is true, while the consequence, or the then part, is false. As we can see, that if B then A runs false when B is true while A is false. Lastly, we will see now the if not B implies not A is false when B is false and A is true. And hence you can see that the original conditional and the contrapositive share the exact same truth table values, and thus we can say they are equivalent. However, the converse and the original conditional share similar truth table values, but not exact truth table values, and thus they are not equivalent. We also learn about biconditionals. Biconditionals are mostly used as definitions. There is lots of other applications, but you'll see a lot of biconditionals as simply definitions. Alright, as you most know, that a polygon with exactly 3 sides is what we call a triangle. So let's have two statements here. Statement A is that a polygon is a triangle, and statement B, the polygon has exactly 3 sides. You're going to notice that for one to be true, the other one must also be true. And what we call this is we actually say A implies B and B implies A. Or another way of saying it, which is probably more common, is we say A if and only if B. Now putting A and B statements back in, we would read this as a polygon is a triangle if and only if it has exactly 3 sides. Now I want to talk about the difference here than the previous example. This one's different in that if I told you I have a polygon that has only 3 sides, then it automatically implicates that this polygon is a triangle. As well as if I told you I have a polygon with a triangle, you automatically know that this polygon has exactly 3 sides. So this one actually goes both ways. And therefore, we really treat biconditionals as equivalences. A is equivalent to B. Alright, now let's look at the proof of the biconditional. So to prove a biconditional, you have to show that each conditional holds, meaning you have to show that A implies B, as well as B implies A. So what we will do is, again, we will start with our regular truth table of 2 clauses. Here you see the truth tables of A implies B, as we've seen earlier. Here is the truth table value of B implies A. And if you remember back, an AND only holds if both parts are true. And you can see only in the first row and the last row are both implications true. Hence, the first and last row will be true for the biconditional, while the second and third row are false. This really means that a biconditional is true only if both parts have the same truth value.